Hello, welcome to Wednesday. Wow, the week is flying by. It just seemed like yesterday was Tuesday. Isn't it amazing? Now, yesterday we were talking about the area of a parallelogram. Let's say the formula for the area of a parallelogram. Ready, begin. Area equals base times height. Now, we found out that the base is any one of the sides. The height is a perpendicular line from the base to an opposite side. So when we multiply base times height, we get in square measures the area of a parallelogram. That's pretty simple, isn't it? No, not difficult at all. Now today, I want to tell you something. We're in 10.2, the area of a triangle. Now you're thinking, that's going to be hard. That's got to be hard. No, actually, it's not hard at all. All right, first off, I got to tell you something. It's easy to make triangles into parallelograms. It is. All you have to do is draw a congruent triangle, kind of the mirror image right next to that triangle, and I make a parallelogram out of it. Watch this. Any triangle can be turned into a parallelogram. Okay, so I got this triangle right here. I'm going to draw a triangle that would be, of course, a mirror image of it right over there. And guess what I made? Well, a rectangle, it looks like, isn't it? Because that has a square corner. So you can turn any triangle into a parallelogram just by drawing, kind of flipping that triangle over and drawing that, and you have a parallelogram. Okay, well, let's take this one. I'm going to draw that triangle that I have right there. I made another one just like it, and I have a parallelogram. Here, I'm going to draw a triangle. It's kind of upside down, I know, compared to the one that's there. And these two triangles are congruent, and you know, they both make up one parallelogram, those two triangles. Here, I'll take this one and draw a triangle that's just the same size as this one, kind of flipped over, and you notice you can make any triangle into a parallelogram that way. And what I'm trying to say is that every triangle is half of a parallelogram. Yeah, I started with that triangle, and I added that other congruent triangle to it. So what I started with is half of this whole parallelogram. This triangle is half of that parallelogram. This triangle's area would be half of that parallelogram. And that is the basis of how we get our new formula. The area of a triangle is 1/2 base times height. Now remember, the area of a parallelogram was base times height. Because a triangle is half of a parallelogram, the area of a triangle is 1/2 base times height. It makes sense, doesn't it? All right, so area equals 1/2 base times height. So let's look at this triangle right here. Here I have a triangle with a base of 11 meters, that's going across this way, and a height of 4 meters going that way. Well, the area, what's the area? Well, let me write the formula. First, let's say the formula for an area of a triangle. Begin. Area equals 1/2 base times height. You got to remember, you say that 1/2 base times height. So I write the formula, and you'll do that in the practice today. Then I fill in with the numbers. Area equals 1/2, base is 11, height is 4. 1/2, 11 times 4. 11 times 4 is 44. 1/2 of 44 is 22. So I have here the area would be 22 square meters. All right, let's go to this one. Here, let's say I have a triangle that has a base of 3 inches and a height of 7 inches. Okay, so let's write the formula. Begin. Area equals 1/2 base times height for the area of a triangle. So I write the numbers in now. Area equals 1/2, the base is 3, the height is 7. All right? So the area equals 1/2 of 3 times 7, which is 1/2 of 21. Notice I'm doing this straight down, equals under equals, step at a time, don't skip a step. And 1/2 of 21 is 10.5. So you could say 10.5. Either way, 10.5 or 10.5. But it would be 10.5 square inches, because I have measures of inches here. 10.5 square inches. Now if I make it into a whole parallelogram, it would be double that, right? 21 square inches. But it's a triangle, so it's half of a parallelogram. Okay, so how about this one? Here I have the base of 1 1/4 feet, right here, and a height of 6 feet. Now you notice I had to extend the base and then draw a perpendicular line down to the base from that vertices to get the height. But I'm not going to use this whole distance here for the base. I only use the distance between here and here for the base. All right, so the base is 1 1/4 feet. The height is 6 feet. Let's say the formula for the area of a triangle. Begin. Area equals 1/2 base times height. So I replace these. Area equals 1/2, 1 1/4 times 6. Now, I can multiply these in any order I want. We call that the commutative property. In other words, it doesn't matter what order you multiply or you add numbers, you come up with the same thing, right? So 1/2 of 6 is, I can do that in my head, right? 1/2 of 6 is 3. So I'm going to say area equals under equals 3, because 1/2 of 6 is 3 times 1 1/4. Over here I did this. 3 over 1 times 1 1/4 equals 3 over 1 times 5/4. 4 times 1 is 4, plus 1 more is 5, 5/4. Again, I'll simplify before I multiply. So 3 times 5 is 15, 1 times 4 is 4. 15/4 is 3 and 3/4. So I have 3, the area is 3 3/4 square feet for that triangle. That's how you use the formula. Let's say the formula again for the area of a triangle. Begin. Area equals 1/2 base times height. All right. Now, let's find the missing measure. Let's suppose that we're given that area, and we're given the base, but we don't know the height. Okay, so you write the formula. Begin. Area equals 1/2 base times height. All right? So I'm replacing the area with 36, because I already know the area is 36. I have 1/2. The base is 8, so I replace the b with 8. I don't know what the h is. Okay, so 36 equals 1/2 of 8 times h. What's 1/2 of 8? 4, right? So 36 equals 4 times h. Well, 4 times what? Or h is what, right? What times 4 equals 36? 9 times 4 equals 36. So h must be 9 inches. 9 inches. So you can find the missing height, you can find the missing base if you're given the information of the other two numbers. Now you're going to be asked to do this. Find the area of, it looks like a birdhouse, the front of a birdhouse. And you're going to be asked to find the area of that. Now, you have to notice, we have two figures here. There's a rectangle down here, and there's a triangle up there. So the triangle's area, I'm going to find that first. And then the rectangle's area, I'm going to find that. And what will I do with those two? What do I have to do with those two areas to get the total area? Add them, right? So let's find first the triangle's area. Okay, so I have a 10 centimeter, which is, you know, the height. That's from here down to here, 10 centimeters. And you're wondering, there's no number for the base. How do I know what that base is? Well, I'll look at the opposite side, and that would be the same thing in this rectangle. That's 19 centimeters down here at the bottom. So that top part of this rectangle here, that's going to be 19 centimeters, which forms the base, you know, the base of the triangle. So I have here, again, area equals 1/2 base times height. Area equals 1/2 19, that would be the base across here, times the height, 10. 1/2 of 19, I can't do that in my head. How about 1/2 of 10? Yeah, that's 5, right? So I'm going to say area equals 5 times 19. I multiply that out and I get 95 square centimeters. Now that's just up here. Now the area for a rectangle is the length times the width. So I have a length, which is the longer number always, 23 centimeters times 19 centimeters. I work that out, I get 437 square centimeters. All right? Now I got to add those two together. The area of the triangle with the area of the rectangle. 95 plus 437 adds up to 532 square centimeters for the whole thing. So if you look at that and you get overwhelmed, you don't have to. Just think of them as separate figures. We know enough now to be able to find the area of those two figures and add them together. Hey, I have a special guest. Mr. Frazier has a special guest coming Friday. Can't wait. Here we are Wednesday already. See you later.